Okay, 2014, question 2 on the Calculus AB exam. So in part A, you are asked to solve rotational volume. And we are rotating about the line y equals -2. So I'm going to draw just a line underneath. It's not to scale, but that's fine. And then I'm going to draw the radii that I need for using the disk method. So from the axis of rotation to the furthest function between the two functions in the region, from the axis of rotation to the closer of the two functions. Now for the disk washer technique, as I set up my integral, I know that my radius is coming out perpendicular to the axis of rotation, and the teensy tiny width is a change in x. So this is a dx integral. I need to know the x values of intersection. And I believe I put this in a Desmos, or I did not quite put it in the Desmos to go over it. But basically, if I remember correctly, it was 2. Let me double check that answer, because was it 2? I'll just ask you guys. Oh, 2.3. Thank you. That's correct. So using your calculator, you come up with the intersection x coordinates of 0 and 2.3. Then we go into the geometry formula. For the geometry formula, it's pi r squared minus pi r squared. For the outer radius, the top y value is y equals 4. The bottom y value is the axis of rotation, y equals -2. For the inner radius, the top y value is the function f of x. And what's beautiful is on the AP test, you can just say f of x instead of writing this massive expression. And if they don't give you a name for it, you can make up a name that is not used in the problem, but you have to specifically clarify this is this function. So f of x minus the -2 again. And then put that in your calculator. And I'm going to go back to the problem, and let's look at the answer. This was worth a total of 4 points out of 9 points. Every free response problem is worth 9 points. There are only 6 free response problems in the entire exam. Those 6 problems make up half of your grade. The other half are multiple choice. So just to get a feel for how much 4 points means. And 2 points for the integrand are you being able to correctly set up the area formula with the functions inside. The limits, they are referring to the 0 and the 2.3. To get the answer, you need to have the rest of, you have to have the problem set up correctly. If you lose one of the points in the previous 3 points, you're not going to be able to get the answer point. Not for part A anyway. But if you make a mistake, say, on the limits, and continue to use the limits in later problems, as long as it does not change the meaning of the problem itself, they will be looked at as correct from then on. So then we move on to part B. With part B, it says that you have cross sections perpendicular to the x-axis. They are isosceles right triangles with the leg in R. So I'm going to erase this previous work, and perpendicular to the x-axis. That alone says draw a vertical line only in the region itself, and that is the length of one of the legs of an isosceles right triangle. So either you remember the formula or you come up with it. If you know the length of the leg of an isosceles right triangle, well, it's basically just half of a square. So your area formula is going to be 1/2 length of side squared. Then you're going to be using the same limits as you used in Part A. And again, if you have incorrect limits in Part A and use them here, they are seen as correct as long as it doesn't change the meaning of the problem. And then left over is y top minus y bottom. The y top is y equals 4. The y bottom, f of x. And then put it in your calculator and get a numerical answer. Now I'm going to show you how much the points were worth, or the particular points toward Part B. So you can see that this time there wasn't a point given to the limits. It was just the integrand and the answer. And as long as your integrand setup was correct, whatever limits you used in Part A were considered the correct units in Part B. Also, the reason why they have two possible answers is because you are allowed to truncate, which is what the parentheses is where you just cut it off and don't bother whether you round up or not. And then the rounding up of the third digit. So that's those two parts. Then for the next one, you are right but not solving an equation that will answer the problem. So you have a vertical line dividing R into two regions with equal areas. When I come over here, I'm going to erase my previous picture or what I have in it. And so it's kind enough to say vertical line x equals k. So you've got some x equals k line cuts it up into two equal areas. There are a lot of ways you can write this that are acceptable. The easiest way is if you set up an integral that goes from 0 to k, and I'll fill in the info in just a moment, and say that that is equal to the integral that goes from k to 2.3. So just kind of take a moment to look at that aspect of the formula. Then you need to put in the proper area formula. So for each of these, area is looking at the top function, which is 4, minus the bottom function, which is f of x. And then you need to multiply by the tiny dx, or you will not be able to get area. And then the same thing over here. And I'll say again, if your limits were incorrect in Part A, as long as you have them written in these two spots, the same ones you used in A, you're good to go. So back to the problem and how much it was worth. It was worth 2 points. One is for getting basically an area formula that is correct. So having the 4 minus f of x. Because if you had written f of x minus 4, that would be not giving you the area. And then having it set equal to each other in this broken up way. All right, was that fun? I'm going to stop.